All right, so section 2, we are going to slide up in the notes, and we're going to use, on our calculators, we're going to focus in on, let's focus in on this one here just for some data. All right, so from your perspective, what do you see as the values on this graph? What would you call this first value? 0, 100. Okay, this value? 150. Here? 225. A little harder now. Here? 315. Here? 4 what? I heard 4, 5. Okay, we're going to call those our values. Okay? So we're going to write those on the board since I don't have them in front of me. 0, 100, 150, 225, 315, 4, 5. All right, everybody go to your calculators. And we're going to find the exponential regression equation. Remember, that's going to be in this form. Y equals A times B to the X. So, let's switch. Boom. Uh-oh, I've got values that I need to get rid of. So I'm going to go to Stat. I'm going to go to Edit. And I've got values in my L1 and my L2 column. So we need to learn how to get rid of these values. So here's what you do. You arrow up until you're above the column where it says L2, and now you hit the word clear. But wait a minute, nothing happened. So now you hit the word enter, and the whole column disappears. I'm going to do that again. I'm going to go over to L1. I'm going to go up to the top. I'm going to hit clear, and then I'm going to hit enter, and the whole column disappears. Yes, sir?
Is there a way you can just get rid of like 1 without clearing the whole?
Yes. You could go over that little space and hit delete or clear. And then I think it just deletes that 1. Because sometimes if you put too many entries into your column, then you have to go back and delete a couple. Matthew?
I pressed delete instead of enter.
Did it work?
And it deleted my entire column.
Good.
No, it starts at column 3 instead of column 4.
Oh. You may have to go and reset your system to get that back. To go reset your system, just a very quick watch. Second, memory, reset, option 7, over to all, enter, go to reset, enter, and what I've just did is I just wiped my computer.
Okay.
Now, because I wiped my computer, I can go back to stat, I can go to edit, and what reappears? All your standard defaults, which is a good skill to have if you are completely messed up in the middle of a big exam, standardized test, and you do something you can't avoid.
Yeah.
You can reset your computer.
So how do you get back to that screen? Stat?
Stat, edit. So I'll do it again. Watch stat,
Yeah.
and I just hit enter for edit.
Oh.
All right, so we need to put our table values in. Let me teach you a little trick here. Watch how fast this can be. 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. So if you just go down the first column and then down the second column, good morning, Luke, then it makes it really easy to go. 0, 100, enter. 1, 50, enter. 2, 25, enter. 3, 15, enter. And what did you guys choose for 4? 4, 5. Okay, raise your hand if you do not have your data in. We all have our data in. Usually you guys are faster than me because you're on your keystrokes. All right, next. I need to set what ideas first before I go to my graph and all those other things. Stat plot, good. Second, stat plot. I'm working on option 1. I hit enter. What do I want to make sure? It's on. Is mine on?
No.
No. So how do I turn it on? Okay, push enter. Boom. Is it on now?
Yes.
Could I make my stat plot a different color?
Yeah.
Sure. Okay. Matt, if you notice here where it says X list and Y list,
Yeah.
you could change that to L3 and L4
Oh.
if you put in different columns.
So okay.
So just a different way to approach it. But in general, all the programs default to L1 and L2.
Okay.
So, all right.
L, I accidentally just hit delete over the L2.
Right, and so you'd go over, delete over the L2, and then you'd have to change it. See the word list above the word stat?
Yeah.
Second list, and then you could tell it what you wanted.
Nice.
Does that make sense?
Yeah.
I know we're going off tangent a little bit, but these are important ideas because when you screw up, you got to be able to figure out how to fix it. All right, so let's go back to window, because this is certainly not the window that I want. My minimum x is 0, my maximum x is 4, so I'm going to go 0 to 5. Is it okay if I have an x scale of 1?
Yeah.
In this case, I think so. What do I want my y minimum to be? Well, my y minimum is at the bottom 5 and at the top 100, so maybe what should my y minimum be? 0? Hey, excuse me, 0. So I'm going to go 0. And my y maximum, I'm going to make 105, because I just want to see a little bit above, Mackenzie, the top line. What about my scale? How often do you want a tick mark? Every 50? There'd only be 2 tick marks.
25.
Every 25? Okay. You can choose whatever you want. Every 25. Okay, let's take a look at our graph. It's not bad. I'm going to go back because I want more tick marks. I want a tick mark every 10. You know, I'm having a hard time seeing that. So I'm going to go to second format. I'm going to put some dots on my graph. And now I have a grid. Could you put lines on there as well? Yeah. But a grid gives you a little bit more to work with, right? My grid is in gray, so it's very light, very simple, but just a possibility. All right, now I want to create my line. I want to do that A-B calculation, the exponential regression. So we're going to go to stat. Who remembers where they go? Calc, excellent. Go over to calc. These are all programs.
0.
And why option 0? Because what is that? That's exponential. Wow, look at all these other programs. Those are all different regression programs that we can use. So we hit enter, and it has now activated a program. Presently, Matt, it's pulling from L1 and L2. That's why it's important that we put our information in L1 and L2. If you had your information in L3 and L4, you would have to change those by going second stat. And see above stat, it says list.
Yeah.
That's where you change those.
Okay.
So just in case. But in this case, we have L1 and L2. Why am I going down here to the 4th line? Yeah, I wanted to pump in the information, Abby, into the Y1 equation. Who remembers how to get the Y1 equation? Bethany.
We do alpha trace.
Alpha trace. Could you pump it into Y2?
Yeah.
You bet. Just for the heck of it, I'm going to do that. Enter. So now it's going to take my values, Mary, of A and B, and it's going to stick them into Y2, and later we're going to graph that and look at what it looks like, and hopefully it's going to lay over those dots. I hope. All right? Have I done it yet? No, I need to do what? Tell the program to run. So I go over here, and basically this is, do you want to run the program? Yes, so hit enter. It does a ton of calculations, and it comes up with these numbers. Now, we've agreed on here, and our standard is going to be 3 decimals. So if you were writing this as an answer, you're going to write 104.564 and 0.487. Okay? But you're not going to put those numbers into your equation. RJ, you're going to put your full numbers into your equation to make it as accurate as possible. I told you the story about the rocket that went to the moon, right?
No.
Do you guys know yesterday was Pi Day?
Yeah.
Okay. True story. In the course of one of our space stuff, they were trying to take a rocket to the moon and slingshot it around the moon and get it back to the Earth using just the moon's gravity. But you have to get super, super close to the moon for the gravity to do that, right?
Yeah.
So they used pi out to 30 decimals. They missed because of the distance. So the next time they did it, they used pi out to a couple thousand decimals, and then they didn't miss and it worked. Because multiplying times that great distance, Nick, it was too far out and it missed the moon, and so the gravity didn't catch it and it didn't slingshot it back. Benjamin.
How do you get to that page?
This page.
Yes.
I went to stat, I went to calc, I went to option 0, I went down here to store regression equation, I stuck it in y2 if you remember, and then I went down to calculate and I ran the program.
Right.
So this screen is the result of running the exponential regression program. You with me?
Yes.
Okay. All right. So now if I go back to y1, is my equation in there? Is yours in y1 or is yours in y2? Wherever you told it to go, right? Why is mine in y2? Boom. Now, is my y2 program turned on? How do you know? Because the equal sign is black, right? So I should be able to go to my graph. Please work. Why is my line red? Because that's the selection of y2. Do you guys know you can change the colors? So, all right. Now, why did we do all this? Because we want to make a prediction. Okay? So, let's go to second table. And could you make a prediction for 10? Yeah, 0.0784. Right? What if I had you make a prediction for a number that was not on the table? What if you wanted to make a prediction for 5.2? This is how you do it. Super straightforward. Okay? Remember what Bethany said about alpha trace? Let's get off this screen to the normal screen, and let's go alpha trace. Now, I'm going to choose y2 because mine's in y2. You might choose y1 if yours is in y1. So hit enter. Function notation, parentheses, 5.2. Okay. So you guys know, f of 3 or f of 10 or f of 1, Mike. So this is y2 of 5.2. So what's the value of this function at 5.2? There it is. So you can either go to the table, Margaret, and scroll up and down the table, or you can use function notation. This is going to be really handy, Nick, when we have a large number. Like I say, hey, find the value for 200. You know, you don't want to be arrowing down on your table. It's like, Nick, what are you doing? I'm getting to 200. Oh, just go alpha, trace, choose y1, parentheses, stick in 200, close parentheses, enter, boom, and it'll run the program. Make sense? So you got either option there to do that. How you feeling on exponential regression calculator-wise? This is now day 4. Is it getting better? Better than day 1? Okay, if it's not comfortable, what do we need to do? Practice, okay? Just flip through, find a problem, find a graph, pick points, and go. On any kind of a quiz or a test, I will give you the exact points, Emma, so you don't have to worry about estimating. That way my decimals will be exactly the same as your decimals. So I don't want to make you feel like, oh, what am I? I'm trying to guess what that point is. No, because otherwise our numbers might be off slightly. All right, enough said there. Let's flip back off your calculators. Let's go back to our notes. So these are all the typed up notes of what we just did. The reason we didn't do this graph is because we did this graph in class the other day. I wanted you to have something different. So what did you learn today maybe? How to clear out the Y1 or the L1 column and the L2 column, right? We didn't know that before. Had we done function notation before? Okay, all right. So let's come down here. Now's where the fun begins. All right. Let's graph x squared. Super simple. Boom, there's x squared. I'm not being too particular here. I'm just focusing mainly on this bottom point, the vertex. X squared minus 5, where does that shift? Okay, so let's put a little D5 there and go down 5. 1, 2, 3, 4, 5. Put a dot and give me your parabola. Notice, I am not really worried about major point plotting here. I want basic shifts. All right, let's practice again. What's negative x squared look like? Goes down. Thank you, Chad. So what's negative x squared plus 2 look like? Is it still going down? But shifted where? Up. So let's put a little up 2. This all should, at this point, be review, right? Moving on. X minus 3. What's that look like? It's inside the parentheses. Right 3, so put an R3. 1, 2, 3, put a dot. Is this parabola going up or going down? It's going up, thank you. All right. Plus 2 on the inside, which way is that going? So put an L2 there and go left 2. Now within reason, do all of these parabolas have the same shape? I know they're flipped upside down, but are they all the same shape, right? If you cut them out, you could lay them over each other and they would all be exactly the same. If you hold them up to the light, you know, they look like that, you know. Remember the old trace thing where you put your picture up on the mirror and you try to write through when you're looking at the light or something like that? Okay, so they all have the same shape. We haven't stretched them at all. All right? So now let's take these ideas of movement and let's apply them to exponential growth and exponential decay. All right? You know our standard equation right here. Okay? A times b to the x. And this is what we practiced doing the other day. So let's start with 2 to the x. Michael, Ben, or Harry, 2 to the x. Is that growth or decay? That's growth because the 2 is greater than 1. Excellent. So I'm going to do my first one in blue. So do you remember it has a y-intercept of 0, 1? Who remembers that funny word for this dotted line? Good. I heard you say the P's. Asymptote, right? You kind of throw that P in there. Asymptote. All right, now, you shift to magenta. The only thing different on this 3 times 2 to the x is the 3 times. I don't shift this 3 sideways or vertically. I grab the bottom and I hold it. So take your hand, go like this, lock your hand in place. Now grab the top of your exponential graph like this. And wherever your hand is, multiply that times 3. 1, 2, 3. Did your bottom hand move? No, it holds in place. So you did what to your graph? You stretched it. It's like silly putty, right? You stretch the silly putty. Come on, who's taking silly putty? You plaster it on the comic, and then you spread it out, and then you peel it off, and you have the comic reversed, and then you stretch it, and the comic gets kind of weird. If you haven't done this, you're missing out on your childhood. Okay? So, take the value 0, 1 and go up to 0, 3. And there we go. The most important point on this point, Harry, is the point 0, 3. But notice that magenta line, it's still coming down, camera, and it's approaching where? That asymptote. It's approaching that green asymptote. Did the asymptote move? No, because were we holding it down here at the bottom? Yeah, we were. All right, next, number 5. Growth or decay, Bethany or RJ? Why? It's less than 1. Okay, so this is going to be in blue. Put your 0, 1 dot. Draw your basic decay. That's all I'm looking for. Stephen, these problems should take you 30 seconds or so per problem. That's it. We're done. I know back in section 1, we plotted points. I was just trying to give you a broad framework of what decay and growth look like. Today, we're not focusing on plotting points. We're focusing on shifting, sliding, flipping. That's all we're focused on. All right, now I'm going to draw the exact same graph again over here, but now we're going to do something to this graph. Talk to me. What am I doing to this graph on the second half? Am I sliding it or am I stretching it? So hold the bottom, and now how much are we stretching? A factor of 4. So 0, 1 goes to 0, 4. I'm multiplying by 4. So 1 times 4 is 4. Do I have the same asymptote? You bet. So take your magenta line or whatever color you choose, go down to your asymptote, but if you touch it, you're going to get vaporized. Like a lightsaber, All right. Are we good so far? Do you understand the stretch, Nick? All right. RJ, you holding in there?
Yeah.
Okay. All right, coming down. Tell me what you notice is different about all three of these equations. Okay, the first one's got a plus, the second one's got a minus, third one's got a minus, right? So if this is my asymptote, what does that plus 3 do? 1, 2, 3, right? Is this a stretch or a move? It's a move. That minus 4, what's it do? 1, 2, 3, 4, right? It's just a move. And the minus 5? 1, 2, 3, 4, 5, right? I'm down. I'm 5 down. So let's start all three of these by drawing in the asymptotes. Just to give us a reference. Whoops, that was the wrong color. We all good there? Why did the asymptotes move? Because of the plus or minus at the end. All right, that being said, I'm going to draw the parent function. Would you agree that is the basic 2 to the x? Now, plus 3, where does it go? The whole thing goes where? The plus 3 is outside. Yeah, it goes up. So everybody put a little up 3. And from this dot, this 0, 1 dot, go up 3. 1, 2, 3, and put a dot. Is the shape of the magenta the same as the shape of the blue? Yes. It did not stretch, Michael. It's just moved. The asymptote now is the equation y equals 3. Yes, sir?
For like the second, like when you move up, do you move up from the 0, 0, or do you move up from...
I move up from my important point, the y-intercept. That's really the only point in the whole graph I'm concerned about right now. All right, let's go to number 8. Growth or decay. So I'm going to draw a basic decay. Would you agree that's basic decay? All right, now, minus 4. So Stephen, I take this big blue dot here, and I'm going to take that big blue dot, and I'm going to go down 4. 1, 2, 3, 4. And I put another big dot, okay? That's my new dot. And I want to draw a new graph, exactly the shape of the blue graph, approaching the green asymptote through that magenta dot. You good? All right, let's look at number 9. It kind of puts it all together. First of all, growth or decay? So 4 to the x, growth. Interesting. Remember the order of operations? Parentheses, exponents, multiply, divide, add, subtract. All of these problems we've been doing are what? Exponents. What's after the exponent piece? Multiply, divide. So you see this 2 here? So before you slide it, you what? You stretch it. You multiply it. Okay? So I'm going to go red here. See the 2? Okay? That's a stretch. That's a stretch by 2. So what's 1 times 2? 2. Okay? Notice my asymptote, my original asymptote, Masa, was still the same. It's still that 0. Now, Jaffrey, is when I make the slide. How far am I sliding this point, folks? 5 down, okay? So count from the red dot, 1, 2, 3, 4, 5. How far away am I from the green dotted line? Why am I 2 away? Because it stretched, right? It used to be 1 away and it stretched to 2 away. But I still need to approach that green dotted line. And there we go. Pause for a sec. Questions? Is this a lot like parabolas? The only thing different is we have either growth or decay, Salmon. That's it. All right. Moving on. What do you notice about 10, 11, and 12? What have I added in? The little plus or minus is up in the exponent, right? That's like being in the parentheses. Where does it shift? Sideways, right? So, here we go. First of all, number 6. Emma or Nick, growth or decay? Or sorry, number 10. Look at that number there. Growth or decay? Basic growth. So draw your growth. The minus 2, which way does that shift it? Okay, it shifts it left 2. So the minus 2 is a left 2. So take our main point and go left 2. Thank you. Sorry. Yeah, because it goes opposite of the way it's supposed to. Sometimes when I get too excited, I go too fast. Thank you. Appreciate your love. All right, the plus 4. Where's that go? So from the red dot, I'm going to go up 4. So 1, 2, 3, 4. Uh-oh. My asymptote moved, didn't it, just now? Where's my asymptote? It's up 4, where, right? So it's the equation y equals 4. So put your asymptote in and then draw. Don't touch the dotted line. Do we need arrows? Yeah. So when I am grading this on a quiz, I'm going to look for the location of that dot, that blue dot right there. I'm going to look for your asymptote. I'm going to look for your basic shape. Those are the 3 things I'm looking for. That's it. All right, next one. Luke, Jaffrey, or Harry, growth or decay? Number 11. What do you think? Decay. So draw basic decay. Let's see if I can get this right here. Plus 1 shifts which way? Left. Oh, that's right. For your perspective, that was right. From my perspective, it was left. All right, so I'm going to go left 1. And the minus 3 does what? 1, 2, 3, down 3. I'm going to draw my new asymptote, Tanner. There it is. Looks just like the red one, but down 3. Yes, Matt?
Why would your asymptote be there?
Because it's a minus 3 at the back end. So your asymptote is usually y equals 0, and it goes down 3. 1, 2, 3.
Yeah.
To y equals negative 3.
But your asymptote is 1 less than.
No, my asymptote's at 3. Negative 3.
Okay. Oh, okay.
The distance here, Matt, I got to choose a color. This distance, highlighted in black,
Yeah.
is 3 units.
Oh.
So that's 3 units that I went down.
Okay. That makes sense.
And then this also
3.
is 3 units.
Okay.
So my asymptote used to be at the x-axis. Now it's 3 units down.
Okay.
So you have to understand the difference between a stretch where you're multiplying your original y-intercept by 3 and a slide where you're adding a number or decreasing a number.
Okay.
And the only time you have a stretch, Matt, is when you have a number in front. Like, 3 times 2 to the x. So, all right. Everybody help me. Let's start with the asymptote. Where's my asymptote? -5. So everybody draw in your dotted line at -5. All right. 2 raised to the x plus 3. Growth or decay? Growth, sorry. Stop. There we go. Draw your basic growth. Put your most important dot on there. Plus 3. Draw it. See if you get it right. When you have it down, look up. Look up. Did you move it left? Good. Where does the green -5 cause it to go? From the red dot, go down 5. 1, 2, 3, 4, 5. May I touch that green dotted line? No. Now, what's the answer? Which one's the answer? Green. What's the red and the blue? Are they the answer? Do you need them? No, it's like your work. You know, if I said solve the cubic equation, x cubed plus 8, you're going to do a lot of work. You're going to factor it with the San Diego Padres idea. Review, x plus 2, parentheses, x squared minus 2x plus 4. You're going to solve each one. X equals -2. And then you're going to get x equals 1 plus or minus I root 2. And there was a lot of work to get to that, right? That's all that work is these other little graphs. So you don't need them in your final answer. But I'm always going to have all of this stuff on my solution key because I want you to see how I got there. But technically the answer, if this was like a standardized test or something, it would just have the green one. And it would probably highlight this point right here. And you would know on a grid where that was. And you'd have to kind of figure out how did they get there and why. So just to kind of give you an idea there. All right. Now, this is awesome. This is one of my favorite parts today. All right, everybody draw your standard growth. Remember my parabola? Y equals x squared? And y equals -x squared is what? Okay, now, I need to teach you something about parabolas. Parabolas have an axis of symmetry this way, right? Okay? But the vertex is kind of its base. And so if the vertex is here, like my sternum, if I go like that, it's -x squared. True? So if I put a negative in front, realize that really means -1 times 2 to the x. So take this +1 and multiply it by -1, and where do you end up? At -1. Okay? Down here. My asymptote is still in the same spot. Whoops, I just erased that, sorry. So I still have an asymptote there. Why did my asymptote not move? Because I didn't add or subtract anything. So that's a vertical flip. So when you have a negative sign, Abby, in front of the exponential, it's a vertical flip. Like so. Watch my thumb. My thumb is up. Now my thumb is down. It's a vertical flip over this line. Okay? Vertical flip. When does that happen? When the negative sign is in front. Now, let's draw the next one. 2/5, growth or decay? Decay. Draw decay. What happens when you put a negative sign in front? Vertical flip, right? Oops, I should have done that in green. If I'm going to be consistent. Is my asymptote still the same? You bet it is. Do you remember the other day when I talked about our allowance example and giving you, $5,000 a day or $5,000 a week versus 1 penny on day one and double it all the time? Remember how fast that went up? Okay, our lines, this is really bad. That's why I'm saying it. This is really bad. That's not going up nearly fast enough. Okay, you see how this is shooting up like this, very vertically? Your graphs really should be shooting up, Nick, extremely vertically. Just aggressive. Very aggressive. And in the same way, they should be flattening out very quickly. So if you're kind of trailing off like this at a slope of 1, ooh, not good. Okay? You want to be just, because remember, by the time you got to 31, what was the money value? Wasn't it like $20 million or something?
Yeah.
So by the time you get over to 30, you're up at 20 million. Okay? I don't even know how high that is. 20 million feet. I don't even know if that's the moon or not, so it'll be interesting to figure that out. So, all right, let's look at our next one. 2 to the x, growth or decay? Growth. Negative in front, what's it do? Vertical flip. -3, what's it do? Takes the big magenta point and moves it where? Down 3. My asymptote. I need to draw on my asymptote. If you don't draw your asymptote, Chad, you'll have no idea what you're supposed to approach. No idea of your target. All right? So you need to have your target in there. Without that asymptote, there's no reference. So it should look just like magenta, but pulled down 3. No, just slide it down. We're not stretching this. Reminder, what would cause this to be stretched? Where would I have to stick a number? Come on, someone be brilliant here. Yeah, put a number out here. Instead of this minus sign, maybe say like 5 times 2. 5 times 2, that would be a stretch, but no stretches right now. Questions so far? So now we talked about flipping. Where haven't we flipped yet? I have not flipped this way yet, right? Actually, if I do it right, here's my graph. If Helena is the y-axis, to flip, I can't just spin. I have to flip. See how I'm flipping over her? Okay, she's the axis of symmetry. I'm not just spinning. Okay, you're actually flipping over something, like so. All right, and I'm guessing the next ones are doing that. What do you know? It's amazing. All right, 9/50ths. Growth or decay? What do you think, Mary and Matt? Growth or decay? 9/50. Decay. Mary, you agree? Because it's less than 1. So let's draw a decay, guys. There's basic decay. All right. If you go to the dentist, you'll see this graph in the dentist office because they talk about decay all the time. See what I did there? Yeah. All right. Now, I want you to imagine this y-axis. Okay? And I want you to imagine I'm picking this y-axis up and I'm spinning it. Okay? So as I spin this, you get this. Do you see me spinning the y-axis vertically? I'm just back and forth. Notice anything? What did it become? Decay, blue decay, just became magenta what? Growth. Isn't that cool? I think this is so cool how those are related. Here's why. Sidebar. Algebra 1 question. What is 2/3 to the -1? It's 3/2 to the +1. Remember that rule of exponents? A negative exponent causes the fraction to what? Flip. Well, 2/3 is decay. What's 3/2? Growth. 2 is growth. What happens if you flip 2? It becomes 1/2, which is decay. So if you start with growth and you flip it, you're going to get decay. I just think that's so cool, how that flips. So negative exponents cause fractions to flip. And when a fraction flips, it goes from growth to decay. So, summary so far, flipping vertical, put the negative out front. Flipping this way, put the negative up in the exponent. How do I slide up or slide down? Where's my number? Outside. How do I move right or move left? In the exponent, right? Plus or minus in the exponent. All right, you guys are doing great. Here we go. 17. Growth or decay? Growth. A growth function to a negative exponent becomes decay. Because it flips over the y-axis. Questions? All right. Function or no function? Why? Vertical line test. Good. Fails. Not a function. Are these functions, 17 and 16? Oh. By the way, these words are not just chosen randomly. Consider the parent what? Kind of tells you it's a what? It's a function. Okay? Putting it all together. All right. Now we're going to jump all over the place. Each problem is going to be kind of here and there and everywhere. Who feels right now, just give me a show of hands, kind of on a thumb. Where are you right now? Show me where you are. Most of us are between halfway and 3/4. Is that about right? Yeah. Okay, that's okay. This is day one. Here we go. First of all, 3 to the x, growth or decay? So draw growth. Put your big dot in. X plus 1 in the exponent. Talk to me. Talk to me here, Margaret. It's in the exponent. It's this way, but which way of those two? Yeah, nice. It's left. Is my asymptote still at y = 0? You bet it is. If you do not draw an asymptote on your graph, I'm going to assume it's y = 0. If the asymptote is anywhere other than y = 0, I want to see it. Fair? Okay. 20. Now I took the graph from 19 and I multiplied it by 2. So I'm just going to put the green dot there. And I'm going to put the blue dot there as my starting point and my second point. Take that green dot, the y value, and multiply it by 2. What do you get? You go up to 2. But your asymptote does not change. Why does my asymptote not change? There's no minus or plus at the end. If you need help with asymptotes, see Stephen Ryan. He's the asymptote expert. All right, over here. So now, our original parent function was the blue dot. Our left shift was the green dot. Our stretch vertically is the red dot. And now I have to deal with the -4. Where does the -4 go? Down 4 from where? From which dot? From the red dot. So from the red dot go 1, 2, 3, 4, and you got the black dot. The asymptote goes from the x-axis down 4. 1, 2, 3, 4. Nice catch. Who said that? Michael, thank you. So I'm going to draw a black growth function approaching the green dotted line. Boom. Did it help when I did that one in steps? Instead of throwing it all on one graph? I hope. How you feeling? So? All right, let's keep going. Nick, growth or decay? Decay. So draw a decay. X minus 2. Cameron, Sammy, what do you think? To the right 2. Boom, boom. Okay, so I'm going to come over here to 23, which is very, very similar. There's my green dot. There's my blue dot, my original. I have a 4 on the outside front. Remember we took our baseline and we held it here? We grabbed our graph, and now I'm going to stretch it by a factor of what? So, stretch it double, stretch it triple, stretch it quadruple. So, my point, which is presently the green dot, which is at the y value of 1, I multiply the y value of 1 times 4. That gets me up to here. Is there anything at the back? So where's my asymptote? Yeah, at the x-axis, at y equals 0. So go ahead and draw it. Magenta is my answer. It is. Oh my, thank you. There we go. Even though it looks like it's going to slice through that green line, is it? Okay. Okay, so now I have this point up here, that magenta point. Where am I going now from that magenta point? Up 3. All right, I'm going to make a black dot for my up 3 from magenta. 1, 2, 3. I know I'm off the graph. Where does my asymptote go? Up 3. Don't forget what Navia said. This is decay. There we are. The blue line is my answer. What else could I give you on this? What else could I do? The only thing else I could have done is put what? A negative in front. And so instead of multiplying by positive 4, you would have multiplied this by negative 4. What's 1 times negative 4? Yeah, it'd be down here at negative 4, right? It's a flip over the x-axis, like this. That's all I could have done. I can't do much else. That, in my opinion, is a hard problem. Okay? That's a hard problem. All right, let's look at our last sequence. 3 to the negative x. Well, I know that this is growth. But what have I learned about a negative x? It's a flip over what? Yeah. So flip it over the y. And you guys know that growth flipped becomes decay. All right, so now I have this negative 2. I have my decay function. And I have a negative 2 out front. So now I flipped it over the y. Now what am I flipping it over? The x. So my value of 0, 1 here, RJ, multiplies by negative 2. So I come down here to negative 2. There it is. But is my asymptote still the same spot? It sure is. I flipped decay. Because remember your order of exponents. You do exponents first, then multiplying and dividing, then addition and subtraction, which is why as we're moving over, what's my final step? So I take my blue decay that's flipped over both the x and y axis, and I'm going to take that, I'm going to add 4 to this blue dot. 1, 2, 3, 4, and I'm now at this dot. I went up 4. Okay, so this is up 4. My asymptote also goes up 4. So this looks just like the blue, but it's up 4. So your progression is across the screen. We started with growth. We went to decay. We took that decay, we multiplied it by negative 2, so the positive 1 value, Mike, multiplies by negative 2, becomes negative 2, same asymptote, and then we shifted our asymptote up 4 to get to our final spot. How you feeling?